Try and do it a little smaller so we have room.
While I eat my dinner. This is a great dinner. Nicole, what did you call the dinner?
It's carbonara pasta.
Oh, it's carbonara pasta. And it was really good. I'm really sad that you guys, I'm just sad for you guys that you didn't eat this dinner.
I had some, it was delicious.
Maybe we'll post the recipe in the description.
We all know you're not gonna have enough time for that. Negative, positive.
Good job, Ben. Okay. Here's another way you can do this. We're still gonna do superposition, right? But we're gonna use our knowledge that cascaded gain stages, they multiply. And then you can find the output that way. So this stage here, if you just look at it and isolate it, you have a negative feedback stage, which is good, so we can analyze it. Because of the negative feedback, we impose the assumption. So we impose a virtual short between these two inputs. So we know that there's V1 volts here. And then we also impose that there's no current going into the inputs, okay? Same thing over here. There's negative feedback. There's virtual short, so there's V2 volts here, right? Now, if we did superposition, what happens? So let's start here. V2 goes away just temporarily, and we're gonna short it to ground because it's a voltage, right? Remember, if it were a current source, we would open it. And just be a broken circuit there. We're gonna call this V out 1 to remind ourselves that it's a temporary output. The gain of this stage alone, if we call this VA like we did before, it's VA over V1 equals negative R1 over R2. Okay, this comes from just analyzing this stage isolated by itself, right? For those of you who watched my amazing op-amp video, that was so crystal clear with no static on the microphone. You saw how we derived this. So I'll just keep it here for now as negative R1 over R2, okay? So basically you derive it by doing a node voltage at this node and then work it out, and this is what you'll get. All right, now VA over V1, well, let's do this. That's what VA over V1 is, and then if we bring V1 over, so VA equals V1 times negative R1 over R2, okay? So this is the voltage right here, so I'm gonna relabel it as V1 times negative R1 over R2. All right, so now this is the input going into the next stage. Okay, so if we look at just this stage, we know that just isolated, it's got negative feedback and it's in, oh, I'm sorry. Excuse me, guys. This is good. This is good, I made this mistake. You're welcome for making a mistake. This op-amp right here, what kind of stage is it? It's not an inverting input, right? The input, the source is going into the non-inverting input. So the gain, VA over V1, is not what I said. It's not negative R2 over R1, or R1 over R2. It's 1 plus R1 over R2. See, this is, and I made this comment in my op-amp video that instead of relying on memorized gain equations, you should always figure out the gain by using no voltage. I almost made that mistake. I did make the mistake, and then it would have been wrong. So this is the gain, 1 plus R1 over R2 of this stage because it's a non-inverting stage, okay? Watch my other op-amp video to see how we derive this. All right, so this, bringing V1 over, solving for VA, that's what V1 equals, and so, or that's what VA equals. VA equals V1 times 1 plus R1 over R2. So that's the voltage that's right here, and it's the voltage that's going in to the next stage, the next op-amp stage. Now this stage is different, right? The source, or this voltage right here, is going into this inverting input, the negative input. And we know that the gain of an inverting input op-amp stage with negative feedback, of course, is negative R2 over R1, or in other words, it's negative it's the negative of the feedback resistor divided by the source resistor, if you will, right? So we know that Vout1 divided by the input, V1 times 1 plus R1 over R2 equals negative R2 over R1. Right, negative R2 over R1. Okay, so this is messy, sorry. So now we have an equation of just Vout1 and V1. All right, so let's break that out. And I'll probably make a mistake somewhere doing this live, but let's break it out. So
You're trying to get Vout1, so
I just want to put Vout1 in terms of V1. So I just have to multiply the denominator over. So Vout1 equals, this whole thing comes over. It's negative R2 over R1 times V1 times 1 plus R1 over R2.
yes.
Right? And then let's go ahead and bring R2 over R1 into this term. And so this equals negative V1 times
R2 over R1.
yeah, so I kept the negative out, right? So negative's out. So now it's R2 over R1.
Plus 1.
Yeah, plus 1. Ah, nice. Look at that. Okay, so let's analyze that real quick and see if it makes sense. The gain of a non-inverting stage. You want more?
I'll take it.
Okay, thanks. The gain of a non-inverting stage is the feedback resistor divided by the source resistor plus 1. And so this looks like we're in the right form. And then the gain of an inverting stage where the source goes into the negative input is the feedback resistor divided by the source resistor, but it's the negative of that. And so the resistor values are kind of confusing because here you have R2 and then R1, then R1 and R2, so you can't really see it, but the form at least looks good, right? So that's what Vout1 equals. That's our partial answer for this problem. Okay.
That's the one of the two.
Let me put it right here. So Vout1 equals negative V1 R2 over R1 plus 1. Right? Now we got to find Vout2. And Vout2 is the output, the partial output solution as contributed by V2. V2. And then we ground out we short out the V1 source. Okay, so this is what our solution looks like, or our circuit looks like. We got to find what V2 is, okay? So,
just for kicks.
Sure, yeah. All right, so looking at this, here we have ground going into this positive input, right? So that means we have ground here. This guy really shouldn't give us anything.
It's grounded over the top from each other resistor, so this is non-existent.
Yeah. Right, so let's flesh that out. Let's say you couldn't see that immediately, and I may be making a mistake too. So let's make sure we're correct, right? So we know because of our virtual short assumptions that there's 0 volts here, and so therefore there's 0 volts here, right? There's also 0 volts over here, and wherever you have voltage the same on either side of a resistor, there's no current flow, right? The current can't flow from.
We just dropped you.
Can we leave that up? Current can't flow from the same potential to the same potential. All right, so should I close it?
So, going back to it. Sorry.
All right, so you kind of see why this won't give you anything. If you still can't see it, then go ahead and flesh it out and say, okay, I know that since this is a non-inverting stage, that V out over V in, so VB over 0 equals R1 over R2 plus 1. Well, already you bring 0 over the other side, VB equals 0, right? So there's 0 volts here. Okay, so you can still kind of flesh it out with the equation and kind of prove to yourself there's 0 volts right here. All right, so that brings us to this stage. The input to this stage, now check this out. This is no longer an inverting stage. The source is on the non-inverting input. It's on the positive input. And so the gain for this stage, the equation is now different than what we used before, because before the source was coming in on the negative input, but now it's coming in on the positive input, okay? So we know that V out 2 over V2 equals the feedback resistor minus the other resistor plus 1, right? And so V out 2 equals V2 times R2 over R1 plus 1. All right, that's what V out 2 is. I'll write it over here. And look, we have the same term. That's so nice. Right here we have common terms. And so V out total equals, you put these two together, that term's common, so I'll just write it. R2 over R1 plus 1 times V2 minus V1. Is that the right answer?
That is V2 minus V1 times R2 over R1 plus 1. That is correct.
Hallelujah. Have fun, guys.